Okay, now we're going to do the sampling distributions lab, and the key idea here is that when you sample a population, you get a sample mean, and that sample mean might be close to the true population mean. It could be a long ways away from it. It could be way below it or way above it. But most of the time, that sample mean is going to be probably near the truth if the sampling is representative and random, right? But every once in a while, a Bill Gates ends up in the sample and it pushes the average way up, right? Because Bill Gates is just as likely to be in the sample as I am, but Bill Gates's income is well above the mean, where mine is right at the mean, right? There's a lot more average earners in the United States than there are extremely high earners like Bill Gates, right? But the probability that Bill Gates in the sample is the same as me being in the sample, right? So most of the time, a sample mean is going to be near its true population mean. Occasionally, it's going to be maybe much lower than the population mean, and occasionally it's going to be much higher than the population mean. That all suggests that the mean, the sample mean, follows the distribution, right? And that distribution is normal if the sample sizes are large. If the sample sizes are large, then that mean is going to follow normal distribution, right? And as that sample size gets bigger and bigger and bigger, the normal distribution gets skinnier and taller, right? It gets taller and skinnier. Okay. Now, for small sample sizes, if the underlying variable is normally distributed, like maybe tire wear on tires that you manufacture, if tire wear is normally distributed, then the sampling distribution of sample means is going to be normal. Now, if that's not the case, you need a sufficiently large sample size, say 30 or 50, right? Okay. So before we do that, though, we want to be able to understand how to calculate probabilities under both situations, right? One situation is the variable is not normally distributed, which means you have to use a t-distribution if the sample size is too small, right? You have to use a t-distribution if the sample size is small and it's not normally distributed, right? If the sample size is large enough and the sampling is random and representative, then you can use a normal distribution, okay? Both the t-distribution and the standard normal distribution have been standardized. The mean is 0 and the standard deviation is 1, right? But if you have a small sample size, and you don't know the population standard deviation, the t-distribution is going to be shorter and wider than a standard normal distribution. But as that sample size gets bigger and bigger and bigger, the t-distribution gets closer and closer and closer to the normal distribution. So under large samples, you can just refer to the standard normal distribution. Okay. Now, standardizing means what? You've taken a variable and you've demeaned it. You subtract off its mean. And then you take those demeaned values and you divide them by the standard deviation. So the result has, which is called a z-score. So the result has a mean of 0 and a standard deviation of 1. So standardizing is really important, right? And you can standardize any variable with a bunch of observations, you can standardize. Okay, I'm going to give you 2 examples right here. In column C, we have sandwich length. In column E, we have car prices, right? Now, I can't compare inches to dollars, right? So what I want to be able to compare these to those, I want to calculate the z-scores. So to calculate the z-scores, I'm going to take the first observation, 12.1 inches, I'm going to subtract off the mean. Mean here, I've named C3M the mean. And I'm going to divide by the standard deviation. Now, I've defined C4 as S. S is the standard deviation for sandwich length. So a standardized value of 12.1 is 1, which makes sense because 12.1, if I add 12, the mean, to 0.1, 12.1 is one standard deviation above the mean. 12.1 is one standard deviation above the mean. 11.9, if I subtract the standard deviation from the mean, 0.1 subtracted from 12, I get 11.9. 11.9 is one standard deviation below the mean. And then I have 12.02. 12.02 is 0.2 standard deviations above the mean, right? 0.2 standard deviations above the mean. If I multiply this by 2 and I add it to 12, I get 12.02. So 12.02 is 0.2 standard deviations above the mean. Now, car prices, I'm going to do 50,000, first observation, minus this mean, and I've defined E3 to be AVG, mean of new car prices. I divided by SD, standard deviation of new car prices, and I get 1. So 50,000 is just as extreme as 12.1 because both have a z-score of 1, right? So they're both one standard deviation above the mean, right? So now if I compare the z-scores, I can say 50,000 and 12.1 are equally extreme, right? What about the next one? 41,000 is not as extreme as 11.9. 11.9 is one standard deviation below the mean. $41,000 is 0.8 standard deviations below the mean. But 41,000 is not as extreme as 11.9. 11.9 is as extreme as 12.1 and $50,000 because they're all three are one standard deviation from the mean, right? 11.9 is one standard deviation below the mean. 12.1 inches is one standard deviation above the mean. $50,000 is one standard deviation above the mean, right? These three are more extreme than the 41,000. This 41,000 is closer to the mean. It's only 0.8 standard deviations below the mean. Now, what about 44,000? 44,000 is just as extreme as 12.02 because both are 0.2 standard deviations from the mean. 44,000, though, is below the mean because its z-score is negative. 12.02 is 0.2 standard deviations above the mean, right? Above its mean. So I have the z-score. I can compare z-scores to z-scores. I cannot compare dollars to inches, right? And that's the motivation of the why regarding the z-scores. Why do we want z-scores, right? Another reason why we want z-scores is because if we couldn't standardize a variable, we would have to look at infinite many normal distributions, right? Infinite many normal distributions. The normal distribution, there's infinite many of them because there are infinite many values that the mean could take on. And there's infinite many values the standard deviation can take on, right? So by standardizing variables, we can use one distribution, the standard normal distribution, to compute probabilities, right? So now we're going to do question 1 here. Okay, so what I did is I went ahead and I translated this to math, right? I wanted the probability of being lower than. This phrase here, the probability of being lower than, is this part of the math. That right there says the probability of being lower than, right? That's that part. This right here is translated into math. 2.6 standard deviations below the mean. The minus means below the mean, right? By 2.6 standard deviations, right? So I'm giving you a value on the number line. What I want to know is the probability, right? So in statdistributions.com, you click on this link right here, I can graphically find this value, right? So being lower than is a lower tail test or a left tail test, right? A left tail test. The probability of being lower than this value is 0.205, right? 0.205. But I want to know 2.6, right? 2.6 standard deviations below the mean. So I need to type a minus 2.6. Okay. So the minus 2.6 here, the minus 2.6 is this shaded region. 2.6 standard deviations below the mean. That's what the minus 2.6 means, right? And the area that is shaded is to the left of this value, right? So that's this right here. That's this part. And according to statsdistributions.com, the probability is 0.005. Got it wrong because I need it to 4 decimal places, right? We need it to 4 decimal places. So let's use this to figure out how to do it in Excel. So I've given you the Z value, right? The number on the number line. The number line is 2.6. Now I want to find probability value, right? And the probability value is the cumulative probability, right? And the problem says I can use norm.s.dist, norm.s.inverse, t.dist, and t.inverse to find these values, right? And this is a sigma known problem, so we're going to go right into the standard normal. So I'm going to type equal norm.s. Now, norm.s means standard normal distribution. Right? And I have 2 choices, dist or inverse, distribution or inverse. If I type inverse, input is a probability value. That's not the situation here, right? Because I have a number on the number line. So I got to use dist. Dist's first input is a number on the number line. And the number on the number line is negative 2.6, right? And I'm going to type true. True means cumulative distribution, cumulative probability. Cumulative probability. Yep. And this gives me the probability of being less than negative 2.6, right? Just 0.0047. So it's not 0.005. That's not precise enough. It's 0.0047, right? 4 decimals is more precise, right? But 0.0047 rounds to 0.005. Good thing I have allow you to do 2 attempts per answer box, right? Okay. What's the probability of being more than 2.6 standard deviations above the mean, right? So first part is asking for 2.6 standard deviations above the mean, right? .6 is 2.6 standard deviations above the mean. Remember, a standardized variable has a mean of 0, right? And a standard deviation of 1. So this is 1 standard deviation above the mean. This is 2 standard deviations above the mean. This is 3 standard deviations above the mean. But I want to know 2.6 standard deviations above the mean, right? So my Z value here is positive. This part says the probability of being more than, right? More than is the white area. Less than is the blue area. I want the area to the right, not the area to the left, right? So let's get the area to the left first. Let's get the area to the left first in Excel, and it should be pretty close to 0.995. So again, I type 0.600 here, right? This is we want the probability of associated with 2.6 standard deviations above the mean, right? The probability of being less than that number, again, you want to use norm.s.inverse, is I'm giving you I'm giving you a value on the number line, which is 2.6, right? And then you want to type true. Now this is the probability of being less than 2.6 standard deviations above the mean. Okay. I want to know the probability of the white area. I know that my probabilities are going to add up to 1. So this white area plus this blue area is going to be equal to 1. So how to find the white area? Well, I got to subtract this from 1, right? So I'm going to do a 1 minus norm.s.nest. That's going to give me that white area, right? Of 0.0047. And notice it's the same as this, right? That should be shocking because probability of being more than 2.6 standard deviations above the mean is going to equal the probability of being less than 2.6 standard deviations below the mean, right? So this tail probability is going to be equal to this tail probability, right? Now in statsdistribution.com, I can just click right tail and I get 0.005, right? Left tail is the cumulative probability. 1 minus it is the right tail probability, right? Okay. I'll put that right there. So these are the same, right? Which makes sense because it's symmetric. Okay. I want the probability of being within 2.6 standard deviations, right? I want to know the probability of being within 2.6 standard deviations. So let's go here. The probability of being less than 2.6 standard deviations is 0.995, right? In statsdistributions.com. Right? I use norm.s.dist because I give you a number on the number line, which is 2.6. I type true, hit enter. I get the probability of being less than 2.6, right? And then I want the probability of being less than negative 2.6, right? That value we already know is 0.0050, right? Why am I calculating these 3 probability values? I'm going to show you in a second. So this is a negative 2.6. And I'm going to do again norm.s.this because I'm giving you a number on the number line, negative 2.6. Type true. You get 0.0047. So what am I going to do here? I want the area in between, right? I want to subtract this blue area from this here, right? I want to chop off this part. So I subtract the 2, right? Yep. So in Excel, subtracting this little tail here from this gives me 0.9907, right? In statdistributions.com, all I got to do is click on the two-sided mean, right? So this subtracts off automatically, right? See this here, left tail probability, 0.995. Remember, this is 0.005, right? So if I click on two-sided mean to z, I'm subtracting off 0.005, right? You see that? I'm subtracting off that. And I get 0.991. 0.991 is really close to this, right? To 3 decimals, they're identical. See that? Okay, so it's not 0.991. It's not precise enough. It's 0.9907. Okay, now we got to find the value of z now we want to find the value of z, the number on the number line that has a probability associated of 0.21, right? So now we're given the probability value, right? The probability value is 0.21. And we want to know the probability of being less than. We want to know the value of z. The question mark here is z value, right? We want to know what that is, given the probability value of 0.3100, right? And this says being less than z, right? So if the probability is 0.21, that's less than 0.5. So the z is going to be, and it's going to end up being negative. It's going to end up being negative, right? If this were 0.5, the z value would be 0, right? Because 0, the center of the distribution is at 0, with half being lower than 0 and half being greater than 0, right? But since this probability value is so little, we're thinking the z value is negative. So let's open up stats distribution calculator. And I'm going to type up here, we need a left tail probability, right? Why do we need a left tail probability? Because this says probability of being less than. Probability of being less than means we needed a left tail probability. And then we want that probability to be 0.21, right? 0.21. And notice that the z value is negative, right? This probability value, the left tail probability is so small, right? Smaller than 0.5. So the z value is going to be negative, right? Okay, so assume we don't know what that is, right? Let's go to Excel. How are we going to figure this out? Well, now I want what? I want to use norm.s.inverse, right? Why do I want to use norm.s.inverse? Because now I want to plug in the probability value, right? To get the number on the number line. This will give me the number on the number line. And it's negative 0.806, right? So it matches the value in statsdistributions.com. It's negative. Right. Okay, the next thing we want to do is we want to find the value of minus z and z. So here you got to think, if z is 2, then z, that's 2, and this is minus 2, right? If z is 3, this is going to be minus 3, right? So in absolute value, this value and this value are going to be equal, right? So we want to know the probability that the values, we want to find the values of minus z and z such that the probability of being between minus z and z is equal to 0.67. So this is a between problem, right? So if the probability of being between the numbers is 0.21, z is going to be 0.266 and negative 2.66, right? But that's not the case here because we're talking about a probability of 0.67, right? 0.67 is a little wider interval. So the z value is going to be 0.974 and negative 0.974, right? So imagine we don't know this value yet, right? How are we going to find it in Excel, right? How are we going to find that in Excel? Well, in the next chapter, this blue area is going to be called 1 minus alpha, or the confidence level. Right? 1 minus alpha is the confidence level. Alpha is called the significance level, or significance. Alpha is the significance. 1 minus alpha is the confidence, right? 1 minus alpha is the area in between a number and its negative, right? That's the confidence level. And it just so happens it's given to us, right? 0.6700, right? The alpha is the area in the tails, tails being plural. We got 1 tail, 2 tails. So the probability of being in the tails, right? Okay, so remember this area plus the blue area plus this area is equal to 1. So if I subtract this from 1, I get the area in the tails, right? So if I click on 2 tails instead, right, I get 0.33, which makes sense, right? 0.33 and 0.67 add up to 1. So the area in the tails is equal to 1 minus this up here, right? .33. So these two add up to 1, right? This is the area in between, and this is the area in the tails. Now, to find this, suppose I don't know what this number is here, right? To find this number, I need to know what this area is, right? This area plus this area is alpha, right? So half of it is here and half of it is here. So what I'm going to do here is I'm going to divide alpha 2. So this area is going to be 0.1650. So now I want to divide this by 2, and I can do that by doing left tail, right? See that? Here's 2 tails, left tail. 0.33 divided by 2 is 0.165, right? So now I have this area here. How do I find this number in Excel? Well, I'm going to type right here. Again, I'm going to type equal norm.s inverse, because I'm given a probability value, which is 0.1650. So now my z value is a negative 0.974, right? So a negative 0.974. Now we can use symmetry to come up with this, right? Or you just get rid of it. We can take the absolute value of that, which means we have to take the absolute value of that, and we get a 0.974. Right? Let's go back to statsdistribution.com, right? Okay, so now we got to find the upper value, right? Now we got to find the upper value over here. We got to find this value, right? And so that value is going to be this. To find this value here, we have to add the alpha divided by 2, right? This is alpha divided by 2. We have to add the alpha divided by 2 plus the area in between, right? 0.67. We got to add this to 0.67. We got to add those two, right? This is the area in between, and this is the area in the lower tail, right? And so if I get rid of the negative here, we're going to see that, oh yeah, that's the value, right? 0.974, right? And then if I click on left tail, right? 0.974 corresponds to lower tail probability of 0.835. See that? 0.835. Right? So this should be 0.974. Again, I'm going to do norm.s.inverse. And this is my lower tail probability there. And it is 0.974. Yep. Now we're going to repeat the above, but we're going to assume that sigma's unknown. Right? We're going to assume that sigma's unknown. Okay, so I have the basic same setup here, right? Except I've changed my z's to t's. Z is for a standard normal distribution. T is for the student t distribution. And I have a sample size of 30, and I have degrees of freedom of 29, because the degrees of freedom are n minus 1. So if the sample size is 30, degrees of freedom are 30 minus 1, right? So it's the same setup, right? I want the probability of being lower than 2.6 standard deviations below the mean. Okay, so I'm going to open up the here. I'm going to click on student t's right here, student t's, and you have an additional answer, or you have an additional box here, right? This is for the degrees of freedom. This is 29 when the sample size is. Now notice what happens. If the sample size is 2, the degrees of freedom are 1, right? The t distribution is low and wide compared to the standard normal distribution, right? Now, as I increase the sample size, what happens to the t distribution? It starts to get closer and closer and closer to the normal distribution, right? And they get to the point where a big enough sample size, 200, it's pretty close to the standard normal distribution, right? So we're going to start off with 29 degrees of freedom, right? It's not as tall as the standard normal distribution, and it's a little wider than the standard normal distribution, right? And the first one is a lower tail probability, so left tail, right? And I want to know the probability of being less than negative 2.6, right? So I'm going to change this to negative 2.6. Okay, so the probability value is 0.007 to 3 decimal places. What is it What is it for? Let me fix this real quick. Okay, so the t-value is negative 2.6, right? The probability using a standard normal is 0.0047, right? But here for the t-distribution, it's 0.007, right? Because remember, it's lower and wider. Right? So let's calculate over here in Excel. So here I need to use t dot what? I have two choices, dot dist or dot inverse. If I do dot inverse, I need the probability value. I don't have the probability value. I've been given a number on the number line. The number on the number line is negative 2.6. Now, the other thing I got to enter here is the degrees of freedom. I'm going to click on the 29. Okay, and then I just got to type true. Right. And to 4 decimals, it's 0.0073, not 007, right? Okay, what about if the sample size was 200, right? If the sample size is 200, what do we got? A sample size of 200 is going to give me 199 degrees of freedom, right? Notice the distributions got taller and skinnier. What happened to the p-value? It got closer to, right? 0.005. Let's change this to 200. Yep, the probability is 0.0050, right? Remember what it was when we knew sigma? 0.0047. So as the sample size gets bigger, the t-distribution gets closer and closer and closer to the standard normal distribution, right? So that with a sample size of 200, the probability is going to be 0.005. Okay. Now we want to know the probability of what? 2.6 standard deviations above the mean means instead of this being negative, it's going to be positive, right? So this phrase here, 2.6 standard deviations above the mean, is a positive 2.6. This right here is going to be the greater than part, right? That right there is the probability of being more than, right? Again, I don't know the probability value, but I do know the number on the number line, 0.600, right? Okay, so if I calculate equal p dot dist, I use that as my number on the number line, and I use this as my degrees of freedom, and I type true, I'm going to get the probability of being less than 2.6, right? I'm going to change this back to 30. Okay, so this is a big probability. So if we go back to this statsdistributions.com and you reset this to 29 because we have a sample size of 30, and you set this to positive 2.6, what Excel's giving you, it's giving you the left tail probability, right? We want the right tail probability. So the white area here, this right tail, plus this left tail, the big blue area, plus the little white area, together they equal 1. So I can subtract this from 1 to get this little white tail probability. And I can do that in statdistributions.com by just clicking on right tail, right? So 1 minus 0.993 is 0.007. So here in when this is pointing to the right, what you have to do is you have to put a 1 minus in front of the t dot or the t distributions, right? I get a 0.0073, which is identical to this value up here, right? Which makes sense because of symmetry. Now for a sample size of 200, closer to the standard normal probability, right? Standard normal probability was 0.0047 with 199 degrees of freedom, we're at 0.0050, right? Again, which is identical to the one above. Now we want to know the probability of being within 2.6 standard deviations of the mean, right? So we ultimately want to know this probability, right? We want to know that thing. We want to know what t is, right? So no, we know that what the t's are. We know that we want to know what the probability is, right? So this is 2.600. This is negative 2.600, right? So the first thing we have to do is we have to calculate the probability of being to the left of 2.6, right? So in tdistributions.com or statdistributions.com, we need to do a left tail probability here, right? So this is 0.993, right? 0.993. This is the probability of being less than 2.6, right? So we got equal p dot dist. I'm going to click on the value of the number line that I have, which is 2.6. I'm going to click on the degrees of freedom, which is 189 for a sample size of 200. I'm going to type true. I'm going to hit enter. I'm going to go back up here and change this back to 30, sample size of 30, right? So the probability of being less than 2.6 standard deviations above the mean is 0.993 in statsdistribution.com or 0.9927 in Excel, right? And then I want to subtract off this tail probability, right? That'll give me the area in between. So I want to subtract off this area, and that area is 0.007 to 3 decimal places, but is, whoop, gotta move that back up to 29 degrees of freedom. But it's 0.0073 in Excel, right? So I want to subtract this, that little blue area, from this to get the area in between, right? So I'm subtracting out that little area. So I'm going to subtract the two. And I get 0.9855. So the probability of being within 2.6 standard deviations of the mean is 0.9855. In statdistributions.com, it's 0.985, right? So that's for a sample size of 30. For a standard normal distribution, that probability was 0.9907, right? Again, the t-distribution is shorter and wider, right? But it gets closer and closer and closer to the normal distribution, which is taller and skinnier as a sample size increases. So if we go to a sample size of 200, that probability is 0.99, which is really close to the standard normal probability, right? Okay, then we got 2 more things to answer here. 2 more parts. Okay, we want to find the value of t such that the probability of being less than it equals 0.21. So I'm given the 0.21, right? I'm given that. I want to know the t value that corresponds to that, right? So let me change the sample size back to 30. I want to know the probability that t is less than this number, right? I want to know what the value of the number on the number line. I want to know the value on the number line that results in a cumulative probability of 0.2100, right? So I'm going to change this to a left tail probability, and I'm going to change this to 0.21. So I want to know what this t value is, right, in Excel. I want to know what that is, right? We're going to pretend like we don't know that yet. And we shaded this area to be equal to 0.21. And this is what we want to know here, right, in Excel. So to do this, I'm giving you the probability value. So here you got to use the t dot inverse, right? Because the input to t dot inverse is a probability value, right? And the degrees of freedom. Okay, so we get the same thing, the exact same thing that statdistributions.com got, negative 0.818. That's for a sample size of 30. What about a sample size of 200? For a sample size of 200, we got negative 8.08, right? And both of those, the negative 0.808 is closer than its corresponding value from the standard normal distribution, right? Negative 0.0806, right? So as the sample size gets bigger and bigger, these probabilities are getting closer to the standard normal probabilities, right? Okay, now we want to find the values of minus t and t. So if t is 2, this would be minus 2. If t is 3, this would be minus 3, right? Such that the probability is equal to the probability in between those two numbers is 0.67. So I'm going to change this to a minus t and minus t to t. I'm going to change this to 6.7, right? So the t is 0.991. If I make that negative, I see the probability doesn't change, right? Let's see, the probability doesn't change. So whether it's negative 0.991 or 0.991, the probability is still 0.67, right? So the probability in between is 0.67, right? So the probability of being in between is 0.6700. That's the probability inside two numbers. That's what we call the confidence level, the 1 minus alpha, right? We want to know the probability of being in the tails. And there's two tails, right? The white areas. And to get that in statdistributions.com, you click on two tails. So 0.67 subtracted from 1 gives me the white area. And that equals 0.33, right? So I got to subtract this value from 1, right? I subtract that value from 1, and I get 0.333, right? Now I want to find this value. And so I have to use the lower tail probability. I want to get rid of the upper tail probability. You got to recognize the fact that 0.33 is the probability of being in both tails. Half of 0.33 is what? Half of 0.33 is 0.1650, right? So I'm going to do a left tail. When I click on the left tail, it's going to get rid of the upper tail. It's going to half the 0.33, right? It's going to half that, 0.165. And now I can verify with Excel my t value, my negative t value is negative 0.991. It's t dot inverse, right? And I click on my probability value. Then I click on my degrees of freedom, which I got to change back to my sample size back to 30. So I just verified that the t value is indeed negative. Negative t value is a negative 0.991, right? And then I want to find the upper t value, right? Well, I can use symmetry, right? I can use symmetry, or I can go back to statdistributions.com, right? I'm going to click on two tails, and then I'm going to change this to 0.991. And so what do I need to do here is I want to know what this value is, right? So if I don't know what that value is, how do I get it in Excel? Well, I got to calculate the area, this white area, plus this lower tail, right? So this blue plus this white. And that equals the left tail probability, right? The intersection area and the lower tail probability. Well, that is lower tail probability plus the intersection probability, right? Then I can just pull this down. Whoop. They get 0.991, right? So 0.67 plus 0.165 is this lower tail plus the intersection, right? Gives me 0.8350, and that corresponds to a t-value of 0.991, right? Okay, so now what about the larger sample, 200? These values are closer, right? Now they're closer. They were 0.991 plus or minus 0.991. Now they're closer to their standard normal counterparts, right? Plus or minus 0.99, or plus or minus 0.974. So negative 0.977 and 0.977.